Hi, today we are going to be talking about the different types of variation that can be used. Direct variation and inverse variation are two types, um, and another one is called joint, and there's a fourth one that's called combination, which is just um, it can be direct and inverse happening at the same time. So directly proportional is also another term for direct variation. For inverse variation, another term we could use is inversely proportional. A proportion is like two fractions, like A over B equals C over D. They're equivalent and they're proportional. So if you look at direct variation, let's talk about that first. Direct variation is where two variables are related to one another by some constant k. If you look at this equation, it looks a lot like our, oops, that's supposed to go through the origin. Sorry, that's supposed to go through the origin. It looks a lot like our slope-intercept form, y equals mx plus b, except for this is going to be plus 0 because it's going to go through the origin. As x increases, the other increases. As x decreases, y decreases. Think about an example of something that increases as something else increases. For example, the dollars I make vary directly over the number of hours or with the number of hours I work. The more hours I work, the more money I make. That is called a direct variation. So we'll talk about that one first. And there are going to be three things that we're going to need to do on most of these problems. And one is finding that k value. Finding that k value. You're going to be given an x and a y, and you are going to find the value of k. The second thing you're going to be asked to find is the equation with k plugged back into it. So the model, so to speak, the model of variation. And then lastly, you'll be asked to maybe find the x or y value given the other value. So it is a pretty easy lesson. Let's take a look here at this first example. It says find the constant of variation and the direct variation equation if y varies directly as x. So as soon as you see what type of variation is, I sometimes underline it. Y varies directly as x. And if y is a negative 24, when x is 4, we can find k is a negative 6. Okay, so that's the first question it has asked us to do, is to find k. And then the second thing is we're to write the equation with k plugged in it. That way we can find any value of x given a y value or any value of y given an x value, because it's always going to have this constant here that relates to two variables. So, for example, if I'm making, well, this is not a good example for this equation, but let's say that was positive 6, let's say I made $6 an hour. So how much I make depends on how many hours I work. The more hours I work, the more money I make, and it's based on some kind of constant. Okay, number 2, y varies directly as x when y is 15. Sorry, I messed that up. Let's try that again. My pen, I think I need a new battery in my pen. Let's see if I can get going on this. It is just not cooperating. When y is 15 and x is 3, our constant of variation is 5. My equation is y equals 5x. So we put a box around the constant, please. A box around the equation. Then it says find y when x is negative 2. So you plug negative 2 in for x, and you get y is a negative 10. So we had to do a third piece to this one. Okay, so most of the time I'm going to ask for all three. I'm going to ask you to find k. I'm going to ask you to find the equation that relates the two variables, and then thirdly, I might ask you to find y or x given one or the other. Okay. Inverse variation is when one of the variables increases, but the other one decreases. Their product is a constant. For example, the temperature in my house varies indirectly or inversely proportional with the amount of time the air conditioning is running. Or the number of people I invite to my party varies inversely with the number of games they might get to play. So let's try this one. So where's my pen? There it is. Y varies inversely. So notice this is K over X and not times, okay? The constant is a product of X and Y. So we'll start with that. And then it says when Y is a -3, when X is 4, K is a -12. There's the constant that relates the two variables. Then we're going to rewrite it and put the equation, or put K back into the equation. There's the equation that relates the variables. Now, this one has the third step here. We'll do a new example. Y equals K over X, because as soon as it says inversely, again, I didn't underline inversely. And then it says when Y is 9, when X is 6, so K is 54. There's our constant. So Y equals 54 over X. That way, when we have the equation, that we can use it for any value of X or Y, for any given value of X or Y. So that's really important. That's our model that relates the variables. And then lastly, it says find Y when X is 3 and Y equals 18. Okay, so here are 4 problems, 4 examples. I just want you to determine whether X and Y vary directly. You're just going to look for Y equals KX or Y equals K over X, or neither. So this clearly is Y equals KX, where your constant is a -3, so this is direct variation. Y equals a constant over X, that's inverse. Y equals KX, correct. Here, let's get Y by itself, 0.1 over X. If I want to get Y by itself, I divide both sides by X. It's 0.1 over X, that's K over X, so that's inverse. All right, joint variation is when you have more than 2 quantities that are directly related. How about the area of a triangle is jointly related to both its height and its base, right? Area equals base times height. Excuse me. So let's take a look at this. We'll set it up. Y equals KXZ. It says Z, sorry, didn't read the problem. Let's try that again. Don't get caught up in the X, Y's, and Z's like I just did. You got to read it. Z varies jointly with X and Y. Okay, so again, don't get caught up if Y equals KXZ. You're going to have lots of different variables, A, B, C, all the way to Z. So you have to read it and write it as you read it. So Z is 3, X is 4, Y is 9, 3 equals 36K, K equals 1/12. Now we're going to go ahead and write the equation that relates all 3 of these variables. Z equals 1/12 XY. And then it says find Z when X is 10 and Y is a -2. So it's -20 over 12, and I reduced that. -20 over 12 is that. Z varies jointly. Now we're talking about something that has more than one type of variation. So joint is where you have direct variation throughout the whole thing, but when it's combined variation, we're looking at both direct and inverse. So y varies jointly as x and w, y varies jointly as x and w, but inversely as the square of z. So notice the square part too. Sometimes we'll have the cube of z, sometimes we'll have the square root of z. You just have to read it and write it as you read it, okay? So let's try this. Let me see if I can. All right, z varies jointly as x. So if z varies jointly with x, that's times, k times, and y, and inversely with w. So there's your little generic equation. Now we're going to find k. Z is 320. X is 4. Y is 10. All over 2.5. Throw that in your calculator. Multiply by 2.5, then divide by 40, and you get k is to be 20. Just check it on your calculator. I'm not going to pull up the calculator here. You should know how to get k by itself. Multiply by 2.5, and then divide by 40. Now, write the equation that relates all these variables. So 20xy over w. Then, lastly, it says find z when x is 5. So times 5 times 6 divided by 8. Throw that on your calculator, and you get z is 75. Now, variation is going to involve a lot of word problems. They're not going to be so straightforward with x, y's, and z's and w's and all that. So what you're going to do is use letters of the alphabet that relate to the subjects of your problem. So let's take a look at this. All right, the amount a spring will stretch, right? It's directly proportional to the weight of the object that it's attached to. So let's say S for spring, W for weight. The stretch varies directly with the weight. So we're just going to write that just like that. If a spring is stretched, I can't say that's like a tongue twister, by 10 centimeters and a weight of 8 kilograms, how much will it be stretched by a weight of 3 kilograms? So we got to find the constant of variation that relates these two guys. Let's try to use fractions when we can. If it doesn't come out nicely, we'll use decimals. All right, so 10 over 8 equals k. Actually, well, I'm going to take that back. Let's go ahead and change that to a decimal. Yeah, we can do that. So that's 1.25. So S equals, I'll put a box around both. X equals 1.25 W. And then it says, how much will it be stretched if the weight is 3 kilograms? You have to read it because sometimes it's going to give you, excuse me, I've got a really raspy voice tonight. What is that? 3.75. And our units is centimeters. Don't forget the units, very important. Sometimes we find S, sometimes we'll find W. It just really depends on what it's asking. You have to read it. All right, Boyle's Law. Some of you might have seen this in chemistry, maybe? Biology, chemistry, I'm not sure. I think many of you have heard of that before. Boyle's Law states that for a constant temperature, the pressure P of a gas varies inversely with its volume. So P varies inversely with its volume. Okay, This constant is your temperature, by the way. A sample of hydrogen gas has a volume of 8.56 liters at a pressure of 1.5 atmospheres. So the pressure is 1.5. You're going to try to find this temperature. And then the volume was 8.56. So on your calculators, you're going to multiply 1.5 times 8.56, and you're going to get, let's round to hundreds. 2.84 is what I got. Hopefully you got that too. Let's write the equation. I don't want you answering that last question without giving the equation of the model. All right, now it says find the volume of the hydrogen gas if the temperature remains constant and the pressure changes to 1.2. So this time we're going to find V. So 1.2 equals 12.84 over V. To get V out of there, you got to multiply both sides by V and then divide by 1.2. So you're going to get 10.7. Your volume is being measured in liters. Okay, the illumination, L, in luxes. That's actually a thing. What that is it's the brightness of something. If you ever look at a box of light bulbs, they'll tell you how many luxes it is. The illumination in luxes of a surface varies inversely. So L, I'm going to use a big L just so it doesn't look like a 1, varies inversely with the square of the distance. So D squared. All right, let's go ahead and find K. One meter away, so that's your distance. The illumination is 750. 1 squared is 1, so K is 750. Now let's write the equation. L equals 750 over D squared. And then it says find the illumination if the distance is 2. Don't forget to square it. I used my calculator and I got 187.5 luxes. That's the unit of measurement of the brightness. Okay, we're not going to do all 3 of these pages on variation. I'm going to do this last one and then I'll do maybe 1 or maybe 2 more. All right, the horsepower, H, needed for a water pump varies jointly. So varies jointly means you have direct variation twice of 2 things here. With the well depth and the rate. So a 55 horsepower motor can pump water from a depth of 150 feet at a rate of 990 gallons per minute. So multiply that out, divide 0.00037. So H equals 0.00037 dr. And that says find the amount of horsepower needed. So we're going to find H to pump water 1,000 feet at a rate of 2.7 gallons per minute. And the unit here is just horsepower. Okay, so very important that I think underlining is helpful when you do these. Let's see, we've got direct variation here. Let's see. I'm just looking at my notes to see if there's. I'll go ahead and do this one. The temperature T varies jointly with the product of the volume and the pressure. The temperature of a gas is 294 degrees Kelvin when the volume is 8,000 cubic centimeters and the pressure is 0.75 kilogram. Get your calculators out. You're going to multiply these, and then that's a 0.75. Do 294 divided by that product, and you get 0.049. Then you're going to rewrite this equation. T equals 0.049 VP. And it says find the temperature when the volume is 7,000 and the pressure is 0.87. And you should be doing all of these on your calculator and not just copying these, okay? All right, I'll do this last one. This has a good combination here. All right, a stadium has a seating capacity for 25,000 spectators. The stadium has 25 exits and can be vacated in 20 minutes. That means, you know, if there's emergency, like how quickly you can get them out. So this says the time taken to exit the stadium varies directly with the number of spectators and inversely with the number of exits. So notice I use S for spectators, T for the time, and E for the number of exits. All right, so 25,000 spectators, 25 exits, and 20 minutes. I'm trying to find the constant of variation. And 25 exits. All right, so, oh, is that 20? Yeah, 25,000, yeah. Multiply by 25 and then divide by, well, I guess you could divide this too, I guess. Anyway, you get 1 over 20, trust me. Let's do that as a decimal. That's point 0. No, that's not 1 over 20. Sorry. 25, sorry, 1,000, 20 over 2 over, so that's 2 over 100. So that's 0.02. Don't forget to write the equation. All right, and then it says determine the time for 21,000 spectators to vacate the stadium. There's only 15 exits that are working. So plug that into your calculator, and it's going to take 28 minutes. Okay, all right, so not my best effort here, but the notes to these should be posted in Schoology. Hopefully that'll make some sense. But one of the big takeaways here is that you need to find K, write the equation that relates the variables with K plugged in. No other numbers should be plugged in. And then you'll have to use that model to and other pieces of information to find one of the remaining variables. Okay? All right. Thank you. Have a good day.